Hi, welcome to a new video of my channel. This is the same time value of money series that we are discussing. We have discussed the present value and future value of single cash flows in the last video. This video we have undertaken the power of compounding. How the greater number of compoundings will increase your future values. Let's see what is so great with power of compounding and what and how it can help the investor grow money. Compound interest. We have already seen in the introductory video that compound interest earns more interest than simple interest concept. If the compounding is done annually, that means interest is earned only once in a year, number of compounding is only one. If compounding is done twice, that means interest is earned twice in a year. That is known as biannual or 6 monthly. If interest is earned 4 times a year, that is quarterly compounding, number of compounding would be 4. Interest is compounded monthly, number of compoundings will be 12. So this means with each number of increasing compounding, interest on interest will be greater. Let's see how that works. The formula of compound interest, the sum of money, is present value multiplied by 1 plus rate of interest to the power n number of compoundings. P is principal or present value, I is interest rate percentage, n is number of compoundings. If $1,000 is invested 10% per annum, compounded annually, how much you will have in 7 years, 20 years, 50 years and 75 years. So n is 1, 7, 20, 50, 75, etc. Let's see. The sum of money in 7 years will be $1,000 multiplied by 1 point, rate of interest is 10%, 0.10 to the power 7. That's 1948.72. You can easily calculate this amount in a financial calculator, or you can also use the formula like this is equal to 1.10 in Excel. This is the formula for Excel. In 20 years, the power will be 20, 50, 50 years, 75 years, the power will be 75. Number of compoundings increase, number of amount of future value factor is greater. So you get 6727, 117,391, 1,271,895. So this means the greater the number of years, the number of compoundings increase and the amount increases absolutely. You can see here in 7 years the amount nearly doubles. In 20 years the amount becomes 7 times more. In 50 years the amount becomes 120 times. In 75 years you are a millionaire. The amount becomes 102,071 times. So power of compounding increases with number of compoundings. Rule of 72. This is a very important concept in finance. But this is an approximate formula. Suppose say you have $10,000 or $100,000 and you want to know how long it will take to double your money. So for example, you have invested 5,000 in an account which pays 12% per annum. You want to know how many years it will take to double your money. The approximate formula is 72 divided by the rate of interest. 72 divided by 12% is 6 years. So approximately it will take 6 years for you to double the money if the rate of interest is 12%. If the rate of interest is 10%, it will take 7.2 years. That is 72 divided by 10. This is an approximate formula. This is not exactly the years you are looking at. The exact years will be 6.1. But this is an approximation. This formula is often used as a shortcut. So you can also use it as a shortcut. Rule of 69. This is another formula which is slightly better than rule of 72. The formula is 0.35 plus 69 by interest rate. So if the rate of interest is 12%, which was used in the previous slide, this is 0.35 plus 69 by 12. So 0.35 plus 5.75, 6.1 years. This is approximately correct. So using rule of 69, it will take 6.1 years to double the money of investment. If the rate of interest is 15%, it will be 0.35 plus 4.6, 4.9 years. You can see under rule 72, this will be 4.8 years. So rule 69 gives a more precise answer than rule 79. So for approximation, to generally know how much years, how many months it takes to double your money, you can use both rule of 69 and rule of 72. Now we are coming to an interesting formula, interesting concept, the effective annual interest rate. The effective annual interest rate is very much concerned with the number of compoundings. Suppose say you are given a rate of 10% annual. So your effective interest rate is the same, 10%, because the number of compounding is 2. But what if it is biannual? In the first 6 months, you will get 5% interest rate. So if you have invested $100, after 6 months, you will get 105. After another 6 months, you will get an interest of 5% on 105, that gives 5.25. Total amount becomes 110.25. So your rate of interest on 100 is 10.25%. But if you are compounding on 100 annually 10%, you will get only 10. So your total amount of money after 1 year is 110. You get 10%. So if 6 monthly biannual compounding, you are getting 10.25. You can see biannual compounding, annual compounding. Biannual compounding, your actual interest rate is higher. That is known as the effective interest rate. For effective interest rate, you use the formula 1 plus I divided by m. M is the number of compounding to the power m minus 1. Let's see. Suppose say you are using a formula of 6% compounded quarterly for 1 year. That means you are compounding 4 times in a year. So in that case, 1 plus 6% by 4 to the power 4 minus 1. 6% is 0.06. 0.06 divided by 4 is 0.015, which is also equal to 1.5% per quarter. 0.015 to the power 4, 0.0601, that is 0.015 multiplied 4 times. You can use calculator to calculate this. So 0.0614, so that's effective interest rate is 6.14. If you are using using an annual rate, you are getting only 6% as promised. But if you are compounding quarterly, you will get 6.104. So that means number of compoundings will increase your effective annual interest rate from the par interest rate. If interest rate is 10% quarterly, annually you will get 10%. Let's see if it is quarterly like the above question. 10% by 4, 2.5% to the power 4, 1038, 10.38. So your interest rate increased in nominal 10% to EAR. This is EAR, effective annual rate of interest of 10.38. Your nominal rate is still 10. So you can see we can calculate nominal interest rate given the effective annual interest rate. If the number of compounding is more than 1, your effective compounding will be greater and effective annual rate of interest will be higher. You can use any formula to calculate EAR by taking a P, by taking a particular interest rate, taking the formula 1 plus I divided by n multiplied by n minus 1. We already know what is compounding and what is discounting. We need to know. Compounding is calculating the future value from PV. You deposited 100, PV 10% interest rate for 1 year, you get a amount of 110, which is the AP. So this process is known as compounding, calculating interest on interest. Discounting is the opposite. In discounting, you are given a future value. You will need to calculate present value. It says at the end of the year you will get $100. 1 year, 10% interest rate. What should you get now? You don't want to wait for 1 year. You want to get the money now. We have already discussed this in the slide FLV 3. That is known as finding the present value of single cash flow. So discounting, you can get it from finding the present value. Compounding, you can get it from finding the future value of single cash flows. We have discussed these two things in detail in FLV 3, that is future value and present value of single cash flows. Kindly refer to the previous video, FLV 3. Thank you so much for providing your time. I'm quite happy with today's session, and it is a request Please subscribe to the channel. You can send me a mail, a WhatsApp, write a comment, and I will be hoping to help you with whatever is required, whatever I can do for you, sending more examples and trying to develop more videos. So please subscribe to the channel. Till then, till the next video, thank you so much. Bye bye.